So, coming back to our ancestors, possibly through their trial and error, they develop all these different techniques, different methodologies, what we follow today. And with the understanding of nanotechnology, we are now appreciating some of those beautiful tools what had been developed by our ancestors. So, with these two examples, let me formally introduce the course. So, this is essentially what we will be doing is nanotechnology. These are our keywords, and agriculture. Okay. So, what essentially when we talk about agriculture, we talk about multiple areas of agriculture. One is the crop. Within the crop, you have multiple kind of crops, which includes grains, which includes legumes or pulses, vegetables, and they have different name, like then you have fruit, then you have fodder, spices, a series of cash crops, and this list can go on. Then you have, which is of course a cash crop, sugar crops, and these different crops, say for example this area, and of course you have in this you have flowers, which is a different area called floriculture, vegetables the oliviculture, and they all fall under the horticultural section. So not only agriculture encompasses the crops, this is one aspect. Second aspect of agriculture is animal production. This is the second part of agriculture. Crop production, as I have already mentioned here. So the crop production, animal production. Third aspect of it is, so you see, so within animal production, before I here, you have poultry, fishery, dairy, and of course the meat sector. And apart from it, you have several animals which are being grown or which are being followed for different other applications, like camels. Then you have llamas. Then you have yaks. So there are a series of them. So this is where you have different food products coming out of it. Third aspect of agriculture is your food preservation and storage. Food preservation, grain preservation, and storage and transportation. This is another area which is of prime importance, which falls under a big heading which is called, of course for the grain, the food, if it is not of an animal origin. So this is falls under, in case of grains, it falls under post harvest technology, whereas for food preservation, if it is of plant origin or any kind of vegetative origin, then of course normal plant origin or animal origin, which including from preservation of milk to all the way to preservation of meat and all other products. Okay. And then comes one of the most challenging area of storage and transportation. And in this journey of agriculture, which includes all the production practices, what we do from crop, animal and preservation, these are the three basic area. And here I should include, this also includes, when we talk about flowers, how to preserve the flowers, and they have a lot of usage in terms of cosmetics in the industry, perfume industry, several other industries which has branched out from the world of flowers. Now, having said this, so this is the whole range of agriculture what we deal with, and in terms of nanotechnology, to talk about certain things in the very beginning, that will include the first thing, the basic nanomaterial. This nanomaterial could be several kind. It could be a particle, it could be a tube, it could be a sheet, it could be a gel, or it could be a suspension, some kind of a mesoporous suspension. Okay. Now, when we talk about this wide array of nanoparticles, then you have to realize we have to have different characterization tools to appreciate them. And this is what I was telling you in the beginning. So, we have to use series of characterization tools, which includes your SEM, scanning electron microscopy, STM, scanning tunneling microscopy, high resolution transmission electron microscopy, AFM, atomic force microscopy, XPS, X-ray photoelectron spectroscopy, FTIR, Fourier transform infrared spectroscopy. Likewise, then X-ray diffraction for different kind of surface analysis. You have BET. So several techniques are there, and many more techniques are there which I haven't used here, or which are needed to characterize these particles. So next, when we are applying these particles for some application, then we have to realize at what level we are trying to use them. Say for example, when we talk about using nanomaterial in agriculture, okay. When we are using the nanomaterial in agriculture, we have to understand at what level. Are we applying this to the soil? Are we applying this to the plant? If we are applying this to the plant, are we applying it to the root? Are we applying this to the shoot? Or are we doing a foliar spray? Or a floral spray? In case of animals, when you talk about, because are we giving this as a feed to them, or are we injecting them, or we are using them as skin patches? How we are offering them. Now, in terms of using nanomaterials in agriculture, when you talk about the post-harvest technology, which, if you follow me, just a little, so this part. So we talked about where you are using. So this is where I was trying to explain at what level you are using it in terms of animal production, how you are introducing it. And now coming to the post-harvest technology, which is very critical, because this is where the food which is getting processed out of it from all these different sources are combining. So this is for the post-harvest technology. Okay. Are we adding them to food, or they are just being used for transportation purpose? Like, while we have to transport food from one place to another, we coat the boxes or coat the bags with certain material or something, or is it just that? So you realize the very moment we talk about that we are introducing something into the soil, that means you are infringing into the ecosystem. Or when we say we are introducing something to the roots of the plant or shoot of the plant, or we are doing a foliar spray, or we are doing a floral spray, so that once become the biomass is actually getting into the ecosystem. So all gets into the ecosystem, and eventually this part of the soil what we are talking about is actually allowing these things to become part of the water body. So, in other words, the very moment we are introducing newly synthesized nanomaterial into the agricultural sector, we are talking about introducing newer stuff into our ecosystem, and what will be the impact of it over the years is something which has to be looked upon very carefully. Now, with this chart in front of you, you must be now realizing that why this subject is of so much prime importance for us, that as we are marching, this is for sure that nanotechnology is the future. There is no looking back, and nanotechnology and the different nanomaterials what we have talked about out here, whether it's a particle, whether it's a tube, whether it's a sheet, whether it's a gel, whether it's a suspension, they will all in some form or other will be used in agricultural application. They are already in use. Now, this is inevitable. What is important for us to understand is how we or how fast we appreciate that we are moving ahead, yet we deal with a degree of caution that there are limits, there are thresholds which biological system can withstand, otherwise it will pose a newer set of challenges for us. What will be those modes? Sooner we realize, faster we realize, we'll be able to make a difference. Now, you might wonder that what is and why we are going in the nanomaterial domain. The reason to go to the nanomaterial domain is, I told you in the beginning something, and I will again pull that example what I told you. So this is what you see. You have these crops growing, and once the season is over, the stumps are left which are being burned. Okay. So what is left behind is small carbons. So this is burning of crop residue. So this is the full grown crop. These are after harvest. Now, burning the residue, and then what you are left behind is a mass of carbon. Now, in this process, essentially, when the biomass was there, it was a carbon in a polymeric chain in the form of polysaccharides, pectin, all series of carbohydrates. Now, what do you see here? So these were having complex carbohydrates, proteins, lipids, all containing carbon. Carbon in a polymer, or of course there are other atoms with it, including nitrogen, oxygen, hydrogen and all, but since we are talking about carbon, so we'll just stress upon carbon here. So once you burn, what you are having is just carbon. So what has happened in terms of size, here carbon was at a much more bigger moiety in the form of a polymer. Here size has gone down. Now this small size is now could be made available to the new crop. So in other words, the whole fundamental around which our life is revolving, it is essentially, there is one word which can define it very clearly, it's called self-assembly of atoms and molecules. Of course, the self-assembly is driven by series of enzymatic forces, several templates. Now when we talk about this small size, these are the ones which self-assemble to form those complex structures. So when we talk about nanoparticle, essentially what we are talking out here, we gave the scheme of it, we are bringing down the size to make it more available. So this is what essentially is the reason why we are heading for more nanotechnology application. To give you another angle to this, so say for example, I have to apply fertilizer here, okay. So I'm using this big chunks of salt, say in the form of N, P, K, nitrogen, phosphorus and potash. Now think of it in the light of what I just now told you. If this size goes down to this, this smaller size has much more availability to the plant. So in other words, the finer we go, chances are it will be made more available to the plants instead of having something which is much more bigger. So now from here, the journey from here to here is changing many things. You are changing the surface areas to the volume ratio. In other words, now we are talking about something which has much more exposed surface area. Say for example, just think of this situation. I have a box like this in front of you, and this box has these atoms like this. So the pink ones are the atoms, okay. I'm not doing it 3 dimension, I'm just showing in 2 dimension, okay. So your exposed surface area is all over this. But now think of it, this whole part what I am drawing now is completely unexposed, right. there is no exposed. This is not at all exposed. Only exposed area is the one which is shown in out here, light green. This is the only exposed area. So there is a huge area which remain unexposed. Now, if I reduce it down to the units of threes, say for example, I say I have something like this, I have something like this, something like this. So how many you have? 1, 2, 3, 4, 5. 5 4s are 20. Fine. So 15. I'm just increasing one atom. Now think of the surface area we are talking about. Now this is the surface area we are talking about. Even without doing any arithmetic, you can see the amount of surface area increase what is happening. Now if you add this and you add all of this, you will see the difference. But now when we talk about this small particles, their properties, their reactivity, their interaction drastically alters. There is a drastic alteration in their activity. Now, how to handle this? Is nature equipped to handle it? Possibly yes. But then, nature has a limit. Our understanding will be, so this is what we call as bulk, and this is what we call as nano. This journey, and then of course we talked about their characterization, their reactivity, and several other aspects to it, and their bioavailability, likewise. Okay. So now the question arises, what will be those industrial techniques? So how we can make them? This is another aspect of nanotechnology, industrial production, because it has to go through a whole series of quality control, and then what will be the application guidelines, and what will be the monitoring mechanisms. Okay. So now we realize that when we are ushering into a new era of applying nanoparticles into agricultural domain, then we have to take all these things into account, that how we are going to balance out all these things.